The search for a power supply began in the year 2001 after the purchase of a Ten-Tec Jupiter transceiver. This unit, like most modern ham gear, requires a power input of 11 to 16 volts DC and draws 15 to 17 amperes for the full 100 watts output. When we were learning our ham theory, we learned a power supply used a transformer to change the 115 volts AC line voltage to the needed voltage, then a rectifier to change the AC to PDC, and a filter regulator to set the output voltage as needed. Then along came computers and a new type supply. Shown here is a switching supply that generates the 5 different voltage levels required by the computer: plus or minus 5 volts, plus or minus 12 volts, and a plus 3.3 volts for the processor. As we compare the two types, we see the linear on the right is larger and heavier than the switcher, a weight of 38 pounds for the linear versus a 2 3/4 pounds for the switcher. The switcher is more efficient as well. The interest in converting a computer supply for ham use began with an article in May 2002 QST, the St. Louis switcher. This one worked, but I was not satisfied with the regulation. A 10 ampere load dropped the output a full 2 volts. So began the search of the internet for more information. This website showed promise with pictures and some part numbers, but my German is quite lacking, but they did get my attention. Achtung, 322 volts DC, wow. The French were a bit more helpful with pictures. I could figure out some of what they were trying to tell me. I still needed an explanation of the function of some of the circuits on the board. Then came the gold mine. Being an engineer, I wanted a schematic to work with. This one had it all, as well as plenty of pictures. Although the text was in Danish, a friend had it translated, and we were on our way. The schematic shows that the switcher to be quite a bit more complicated than the linear. But by taking it a section at a time, the design will show how to squeeze all that power from such a little box. The 115 volt line voltage enters through a series of hash filters to a bridge rectifier. This rectifier doubles the line voltage and converts the AC to 300 volts DC. This 300 volts DC is then filtered and passed on to the switching stage. The switching stage consists of a pair of MOSFET transistors. They are switched on and off as required to supply the computer with the power needed, hence the term switch mode power supply. This switching occurs at about 50 kHz. The signal is a square wave rather than a sine wave as used in a linear supply. This 50 kHz pulse is sent through a transformer that steps down the voltage and supplies the 5 separate voltages to the output section. Due to the high frequency of the signal, this transformer is much smaller and lighter than its 50 Hz cousin. The output section uses separate high-speed rectifiers and filter caps for each individual voltage. The inductor is a toroid core wound with separate windings for each voltage level. The voltage control is handled by an IC called a pulse width modulator. It generates the 50 kHz pulse that turns the MOSFETs on and off. When the computer is idle and power requirement is low, the MOSFETs may be turned on 25% of the time and off 75% of the time. If more power is needed, the pulse width widens to say 50-50. To run the CD-ROM or floppy, more power is required, 75 on, 25 off. The modulator uses feedback from the +5 and +12 volt supplies to sense the power requirement. As the load increases, the voltage drops, and the pulse width is widened to restore the voltage to the proper level. As shown here, progress is made in voltage regulation. The light blue line is a St. Louis switcher. Later modifications showed a marked improvement. The latest supply changes 0.2 of 1 volt from 0 to 20 amperes in load. Feedback obtained using the resistors from the output terminals to the pulse width modulator. Since we're not interested in what the 5 volt supply is doing, why give it any control? Hence, remove that resistor. To give voltage control, the 12 volt feedback resistor was replaced with an adjustable trim pot. This allowed setting the output voltage to the desired level. An LED pilot light was also added, as well as all the unused output rectifiers and filter caps were removed. To provide a minimum load, a 100 ohm 10 watt resistor is added to the output. The latest modifications were to replace a 12 volt 10 ampere rectifier with a 30 ampere unit. Also, the toroid was rewound, doubling the wire size to reduce the voltage loss. By raising the output voltage, a problem showed up. At 13 volts or above, the supply shut down. The overvoltage current circuit sensed the change and went into action, removing the control diode, and the problem went away. Shown here are the before and after circuit boards. On the left is the power supply as it comes from the computer. On the right, after modifications. Outlined are the new rectifier and the rewound toroid choke. Again, before and after. As you can see, the on-off switch has been moved to the front panel with the LED pilot light. Not shown are the output terminals on the rear panel. So here is my station. I have been operating the Jupiter for 5 years using a converted computer switch mode power supply. I have had no power supply problems. Using this setup, and with lots of DX coming in, I am kept busy. Converting a computer supply is not as complicated as you might think. A couple of bucks spent for parts and a couple of hours working with a hot soldering iron. Just be careful. There is 300 volts DC inside that little box. Put your fingers at the wrong place and it could ruin your day. This might be what you would be seeing. Thanks for listening.